In this video, we'll be learning how to factor polynomials. The idea is that we want to write a polynomial as a product of other polynomials. Before we get started, let's remind ourselves again of the distributive property. It says that if I have three real numbers, a, b, and c, then a times b plus c is equal to a times b plus a times c. In our last video, when we were talking about multiplying polynomials, we started off with expressions that looked like the left-hand side and then used the distributive property to rewrite it to something like the right-hand side. But in this video, we're going to go backwards. Let's look at a quick example with real numbers. Let's say I have the expression 15 plus 21. Now, for each of these numbers, I can write their prime factorization. For example, 15 can be written as 3 times 5, and 21 can be written as 3 times 7. We see here that the numbers 15 and 21 both have a common factor of 3. Now let's go back to the distributive property. On the right-hand side of the equation, notice that the things that we're adding up have a common factor of a. So if we use the distributive property the other way, what we can do is take the a and pull it out and write it as a times b plus c. So we're going to do something similar for our real numbers here. So using the distributive property, we can pull the 3 out and write this as 3 times 5 plus 7. We're going to be applying this same idea to factor polynomials. When factoring polynomials, if the terms all share a common factor, we can use the distributive property to pull out that common factor. Let's go through some examples. In our first example, we have the polynomial 2x cubed plus 8x squared minus 6x. And what we want to do is factor this. So if these terms have any common factors, then we can use the distributive property to pull them out. So let's start by looking at each term and determining what their factors are. For 2x cubed, we can write this as 2 times x times x times x, since it has 3 factors of x. For 8x squared, well, a prime factorization of 8 would be 2 times 2 times 2, and then x squared has 2 factors of x, and then minus 6x. 6 can be factored as 2 times 3, so I can write this as minus 2 times 3, and then I have 1 factor of x. Now that we've broken down each term, we can determine if they have any common factors. Looking at them, it looks like we have a common factor of 2 in each of the terms, and we also have a common factor of x in each of the terms. Using the distributive property, we can factor a 2x from each of our terms. So I'll write this as 2x times, and in parentheses, I'm going to have the sum of what's left. In the first term, I still have 2 factors of x, so I can write that as x squared. In our second term, after pulling out the 2x, I still have 2 times 2 times x, which I can write as 4x. And then in our last term, we have a minus 3 left. So we've now factored our polynomial. We've written the original polynomial 2x cubed plus 8x squared minus 6x as a product of 2 smaller polynomials, 2x times x squared plus 4x minus 3. In our next example, we have the expression 10xy plus 5y squared. Again, we want to see if each of those 2 terms share any common factors. Well, in the first term, 10xy, we can break this down as 2 times 5 times x times y. And then in our second term, we have 5y squared, which I can write as 5 times y times y. Now, looking at these terms, we see that we have a 5 in common, and we also have 1 factor of y in common. So a 5y can be pulled out using the distributive property. So I'll write this as 5y times whatever's in the parentheses is what's left after we pull out the 5y. So in the first term, after we remove the 5y, there's still a factor of 2 and x, so I'll have 2x left. In our second term, after we remove the 5y, we still have 1 factor of y left. So 10xy plus 5y squared can be factored as 5y times 2x plus y. Let's look at one last example. Let's say we have the expression 22x cubed times y to the fourth minus 55x squared y to the fourth plus 33x to the fourth y cubed. Now remember, when we're factoring, the thing that we're going to pull out has to be a common factor in all of the terms. So let's see what each of these terms have in common. The 22x cubed y to the fourth can be written as 2 times 11 times x times x times x times y times y times y times y. I have 3 factors of x and 4 factors of y. The second term, minus 55x squared y to the fourth, can be written as 5 times 11 times x, and then times 4 factors of y. And then lastly, 33x to the fourth y cubed can be written as 3 times 11 times x times x times x times x, and then 3 factors of y, times y times y times y. One thing to note is that as you get more and more comfortable with this, you don't necessarily have to write down the factorization of each term. Usually, you can just look at each of the terms and figure out what factors they have in common. For what we have here, we see that there's a factor of 11 in each of our 3 terms, and then we have some x's and some y's. The question is, how many x's and how many y's we'll have in common at the end? Well, let's start with the x's. I see that each of them has 1 copy of x, and then we also have a second copy of x. Now, in the second term here, we don't have any more copies of x, so that's all we have in common, 2 factors of x. Now let's do the y's. I have 1 copy of y for each of the terms, 2 copies of y, and 3 copies of y. But then in our last term here, we don't have any more copies of y, so that's all they have in common. I have 11, 2 factors of x, and 3 factors of y. So to factor this, I'll pull out the 11x squared y cubed, and then in parentheses, I'll write down what I have left in each of the 3 terms. In the first term, what's left is a factor of 2x and y. In the second term, we're left with negative 5y, and in our last term, we have 3 and 2 factors of x, so I'll write that down as plus 3x squared. So that's how we would factor that expression. 11x squared y cubed times 2xy minus 5y plus 3x squared. So what we've learned here is the first step in factoring polynomials. We want to look at each term and pull out any common factors. In our next video, we'll learn techniques to help us factor quadratic polynomials, which are polynomials of degree 2.